menu. Now, the last question in your assignment is the ANOVA interaction. If we read it, an amusement park studied methods for decreasing the waiting time minutes for rides by loading and unloading riders more efficiently. You have two alternative loading, unloading methods been proposed, method 1, method 2. To account for potential differences due to the type of ride and the possible interaction between the two methods. So again, the word interaction, when you see it, it's indication of double ANOVA right away. And if you look at the table, you have method 1 for the roller coaster and for the screaming for the log, and method 2 used also for the roller coaster. And there is interaction, and again, interaction, double ANOVA. You don't need to know how things are calculated, but she will probably give you the output and expect you to know how to fill in the blank and everything. Okay, so the ANOVA table, and I'm going to send it to you. You have the SS, we have the blocks, in this case the methods, we have the treatment, in this case the rides, we have the interaction, and we have the error, also called the within, and you have the total. This one is 12. This one is 8. This one is 56. Total 136. So if you're asked, if you're giving this missing a number, you know that they add to the total. So to figure out the missing one, we go 136 minus 56 minus 8 minus 12, and you get your missing one. Degrees of freedom. How many methods do we have? We have 2 methods. So 2 minus 1, 1. How many different rides do we have? We have 3. For the interaction, you multiply them. But now it's a bit tricky. You need to do the total first and then figure out this. The total would be big number minus 1. So if you go to the actual question, when we say capital N, we mean number of numbers minus 1. How many numbers do we have? So 41, 52, 50, 43, 44, 46, 49, 50, 48, 51, 46, there are 12 numbers. So 12 entries minus 1, 11. So we're missing this one, but they add to the total, so we go 11 minus 1 minus 2 minus 2. That gives you 6. So again, I'll go over this slowly for the interaction. When you see the word interaction, it means that it's double ANOVA, because there must be 2 to interact. To do the table, blocks, how many information going this way, or how many methods? We have 2. 2 minus 1, 1. Rides going this way, treatment. And how many rides? We have 3. 3 minus 1, 2. For the interaction, we multiply them. We don't do this one, we go to this one. Capital N minus 1. Number of entries minus 1. There are 12 entries, or 12 numbers, minus 1, 11. And this, you can figure if they all add to 11, then 11 minus this gives you this. We don't need this anymore. Then MS. You know, MS, you take your SS, divide degree of freedom. So 12 over 1, 12. 8 over 2, 4. 56 over 2, 28. And 60 over 6, 10. We go to the F table, or the F test, or the F value. And I told you, you take the MS that's in the same level and you divide by the error. So for the first one, it will be 12 over 10, 1.2. This is 4 over 10, 0.4, and this is 28 over 10, 2.8. So again, F test, you take whatever the MS that's in the same level, and you divide by the MS error. Now Excel, in addition to this, gives you p-value, and we need this because it will make life easier when we make the conclusions and the hypothesis. So when you do this in Excel, for the first one, p-value is 3153. %, and 53. For the second one, is 68, 70. And for the third one, 13, H4. That would be the analysis section for the hypothesis or the calculations. Now we go to the actual question. So we did the Excel. Question B. Test for difference in waiting time based on the ride. And you see, ride is treatment. So B, we have to do as treatment. And since there are 3 rides, mu1 equals mu2 equals mu3, HA at least one is different. In English, true mean of waiting time to load and unload is not different for the three rides, and here is different. Test. We're going to do the F test, which is MS effect over MS error. Decision rule. Now, in all hypotheses we've done throughout this course, or a huge percentage of them, we've done the classical way. For this, it's easier to do with p-value approach. So decision rule under p-value, and this is standard for p-value. If your p-value less than or equal alpha, you're going to reject each zero. And alpha is given to you, I believe, in the question as 5%. If not, if it's not given to you as 5%, we're going to assume 5%. Yeah, it's not given, so we're going to assume 5%. Again, for the analysis, we're good. We only need to do one thing in there. I'm going to erase the last two lines because these are the first three are the major lines. And the analysis, you need to pick which of the three you're going to use for F-test and p-value. Since this one is treatment, which is the second one, my F-test would be 0.4, and my p-value is going to be 6870. Now, I'm ready to make a conclusion. This p-value of 6870, you guys tell me, is this less than 5%? Definitely not less than 5%. For the first time today, do not reject H0. Anytime you don't reject, you have to mention type 2 could be committed with risk equals beta. So we are not rejecting H0. We're accepting H0. We have no evidence of this. So in English, we do not have enough evidence to show that one of the true mean time for loading and unloading is different among the three rides. We have no evidence that at least one of them is different. In fact, they're the same. So this is the answer for B, and we get the information from the table in Excel. So we go now and we do C. Test for difference in waiting time based on loading method. Loading method meaning blocks. H0, HA. Mu block 1 equals mu block 2, at least one is different. In English, true mean time for loading and unloading is not different for the two methods, is different. You might ask the question, well, you said, or I said, that ANOVA for comparing three groups or more. Here, there are two groups. Why we're still using ANOVA? Well, for two reasons. Now, ANOVA is recommended for three groups or more. You can still do it for two, but not recommended. For two, we do it the other way you did earlier in the course. But we could do it ANOVA for two. Plus, since we have the table already, we don't need to do it again. We can just keep doing the ANOVA. So now, for test, we have the F test, and it's always MS effect over MS error. Decision rule. Again, to make life easy, I'm going to base my decision based on p-value. If p-value less than or equal alpha, we're going to assume 5% is not given, we're going to reject H0. analysis. You don't have to do the analysis again since you have the table. We need the F-test. And since this one is comparing methods, blocks, I'm going to take the F-test for blocks 1.2 with a p-value of 3153. Conclusion. P-value of 3153. Looking at the decision rule. Is that less than alpha? Not less than or equal alpha of 5%. So again, do not reject H0. And anytime you don't reject, you say type 2 could be committed with risk equals beta, and you don't need to calculate. Not rejecting, meaning you're accepting that they're the same. We have no evidence that at least one is different. We do not have enough evidence to show that at least one of true mean time for loading and unloading is different between the two methods. Good. So we did the treatment for A, we did the blocks for B. The C question. The D question, sorry. Test for difference in loading time based on interaction between them. So we're gonna do this interaction now. This one is done differently. For interaction H0, we say there is no interaction effect on true mean of loading time, and this one there is interaction effect. on the mean of loading and unloading. So H0 no effect, HA is effect. Test still the same, MS effect over MS total. Decision rule. And since we have the benefit of p-value, we're going to do it the p-value approach. P-value less than or equal alpha. We're assuming 5%. This is true. We're going to reject H0. Under analysis, we all need to indicate what F-test we're going to use. Since this is our interaction, it would be the 2.8. And for the p-value, interaction would be the 13.84. So we are ready to make a conclusion. Looking at this p-value, 13. Is 13.84 less than 5%? No. Not less than or equal 5%. So again, do not reject H0. Do not reject H0. Type 2 could be committed. With risk equals beta, and you don't need to calculate. Not rejecting H0, you're accepting it. There is no evidence of interaction effect. So in English, we do not have enough evidence to show that there is an interaction effect in true mean of loading and unloading time. So there is no evidence of effect or no interaction effect on true mean loading and unloading. So the loading time is the same for the writes, same for the methods, and interaction the same. No interaction, no difference in write, no difference in method. Everything is the same. Good? Now this is it for the assignment. However, there's one more thing that I want to talk about quickly that you might ask in the exam. she might ask you to explain what p-value is, or what type 1 is, or what type 2 error is. So for example, when you do any hypothesis, you do it in symbols first, then you do it in words. Mu not equal 0, true mean not equal 0. Same here, you do it symbols first, and then words. Now assume you do the p-value and it's about 6%. How would you explain what this p-value is? The way you explain p-value, you say this. Assuming H0, I'm going to circle it, is true, the probability of having a sample as extreme as the one in the test equals 6%, or basically what the p-value is. So if you're asked to do the p-value, this is what you say. Assuming H0 is true, probability of having sample as extreme as the one in the test equals, and whatever the p-value is. But instead of saying H0, say what H0 is in words. Assuming that the true mean, whatever. So you have to say what this is in words when you explain the p-value. What if they asked you to explain type 1? Error. Type 1 error, if you're asked to explain it, you say this. We are rejecting H0 when it could be true. This is how we explain type 1 error. We are rejecting H0 when in fact it could be true. But instead of H0, again, you have to say what H0 is in words. And remember, risk of type 1 is alpha, whatever given in the question, and if it's not given, 5%. And how would you explain type 2? To explain type 2, we say we are not rejecting H0 when it could be false. Again, the meaning or the explanation of type 2 is standard. We are not rejecting H0 when it could be false. And instead of H0, you have to say what H0 is in words. Now, type 2 comes with a risk beta. There is a way to calculate it, but you don't need to know. You're not responsible for that. Okay. So when you write down the answers, remember there is an Excel part for the last question. I'm also gonna send, when I send you the links for the videos, I'm gonna send you the Excel. All you need to do is just put it with the assignment and you'll be okay. The other thing, I might send you a review for the final. But again, it's this assignment covers most of the stuff you need, and I added some extra ideas for you to know. But in general, this also could be a very good review for the final exam. So make sure that you understand everything we did today. Plus, if you have questions or if you need extra stuff, you of course can let me know. Other than that, again, I apologize. It's a long assignment. Probably gonna take you 3 hours to write down, but make sure that you understand everything very well. Good luck.